Hi everyone, I'm Instructor Gregory and welcome to Networking Fundamentals. This is Module 1, the very beginning, and we're going to focus on understanding local area networks. So thanks for joining me. I'm really excited to teach you about networking, so let's get started. Alright, so let's do a quick overview of our agenda. First, we're going to discuss local area network and then talk about the data transfer on a local area network, also known as a LAN. And then we're going to feature different types of local area networks that you may run across. Alright, so what is a network? A network is just two devices that are connected to each other with a physical medium like a wire cable or a radio signal. And that connection allows the two devices to exchange data back and forth. Networks have a lot of different purposes. They're used for communication and collaboration inside of a business or an organization. They allow us to share information and resources like your tweets and your texts. And they make it possible for us to organize data, but they also allow us to save a lot of cost because we can share resources like printers and other services that are available through networks. Alright, so how are networks organized, right? We have all these devices around the world, but how are they organized with one another, right? They're organized based on their geographic location. So remember that. Networks are organized based on their geographic location, right? Where they are in the world or in a building or a city. And a local area network specifically is simply a group of computers or devices that are featured in the same small geographic location. All right, so let's repeat that. Networks are organized based on what? Their geographic location, and a local area network, all right, is a group of computers that are featured in the same small geographic location. So think of like a school or a small office. That's a local area network. Now, the computers and the devices on a local area network share a common communication medium. So we have cables, like we talked about earlier, or a wireless connection, right? And these computers and devices are also connected to something called a central connecting device. And we'll talk about those in a little bit, all right? But those are like your hubs and your switches and your routers, right? And these devices are very important for you to learn about. All right, so what devices make up a local area network? We have hosts like your phones, your laptops, desktop PCs, servers, and tablets, right? And we also have central connecting devices, which are your hubs, your switches, and your routers. Now, we typically interact as users with host machines, and those host machines then connect to central connecting devices, which are responsible for relaying our data to other host machines. A host is defined as any device that has something called an IP address. An IP address is used to send or receive information. It is very similar to the mailing address at your house. It helps to identify not only the device, but also the network in which they're located. And if you go back to that home address analogy, a network would be something like your city or maybe even your street block. Central connecting devices are for connecting hosts and also transmitting data. Now, different central connecting devices perform these functions in different ways. All right, so I'm going to show you a model. Okay, first we can start talking about hubs. Hosts send data to a hub, and then the hub broadcasts that data to other devices that are connected to it. Now, this is sort of an antiquated technology. It's very old. It's becoming more and more obsolete. All right, so take a look at this model on the right I have here. Now, if the computer at the top sends its data, every device connected to a hub is going to receive that data. Now, the potential problem here is that this computer may only want to send the data to the laptop down at the bottom of the screen and not to the server that's located at the top right. We're able to correct this problem with the help of devices called switches. Unlike hubs, switches send and receive data to their intended destination. All right, so take a look at the example here on the right. You got data being sent simultaneously, and they also go specifically to their intended targets. So a good way for you to summarize it is that switches are simply smarter than hubs. Let's talk about routers. Routers are at the edge of the local area network, and they're responsible for connecting us to the internet. All right, they act as a gateway to other networks. So routers allow communication between hosts on other local area networks. All these devices connect to each other by way of network adapters, and network adapters are also known as network interface cards. Now, these pieces of equipment make it possible for our computers and even our cell phones to communicate with each other. Now, a network interface card communicate by way of wire and wireless signals. So if you look at the example on the right, wired adapters features an RJ45 port, and wireless adapters feature an antenna and connect to networks using a wireless access point. Ethernet cables are made up of copper wires, and they transmit data in the form of electrical pulses. Now, wireless communication, in contrast, rely on an entirely different technology, radio signals, right? Now, as I said, copper cables transmit data in the form of electrical pulses. So if there's a pulse, then that might represent a state call on, and no pulse then represent a state call off. And we normally say that a pulse will be represented by a 1, and then no pulse will be represented by a 0, right? And this is called binary. You'll learn more about this as you learn more about networking. So here we talk about wireless access points. They provide a central point of access for your laptops and your cell phones and even your PCs. And we can wirelessly transmit data on these wireless access points, which are actually connected to switches and routers. So even though we access a network wirelessly, that data is still transmitted across a wired network. All right, so let's switch mode and talk about data transfer on a local area network. All right, so data is transferred in a serial format. All right, so what does that mean, Instructor Gregory? That means one bit of data at a time is sent, and data can travel in a single bit stream in both directions and to and from. And how it does that depends on the type of connection. All right, even a couple of different connections. So if you look at the model we have here on the right, first we have something called a simplex, right, which means it's like a one-way street. Right, and data can only transfer from one device to another, whereas you have something called a duplex, which is like a two-way street. And this means, as you can guess, data can be sent and received at the same time, right, simultaneously. And there's also something called a half duplex. Now, this is kind of unique because this is like you have a two-way street, but only one of them is in use at any given point in time. So data can be sent and data can be received, but not at the same time. The speed that data travels is measured by bits per second, and that's called the data transfer rate, right? And we signify that data transfer rate, as you can see in my illustration here at the bottom right. All right, so we have the number 10 here, right? And then we have the M, which in this case stands for mega. And then we have the lowercase b. And this lowercase b is a little bit different from the type of data that we store. It represents bits, right? Not to be confused with the capital B, which represents bytes, right? Now, this whole construct that you see I have here, it's called the bit rate. And we use that to measure how fast data transfer over a network. Before data is transferred, it actually goes through a really interesting process. We break down large chunks of data into things called segments, all right? And then address and information is wrapped around that segment, and we call it a packet, all right? So take a look at the illustration I have here on your right. Now, from there, we add a little bit more information in order to make it something called a frame, all right? And then each frame is broken into bits that we can see on your screen. Right? Now, this visual that I have here may be a little bit confusing, But I just want you to know one thing. Data is ultimately going to be represented in bits before it's transmitted across a network, all right? So this whole thing end up taking this form right here that you see, all right? And then it's transmitted over a physical media in binary. All right, of course, when data is received by a device like your cell phone or your computer, it goes through the reverse process. So what happens is that the receiving computer is going to take all those bits and it's going to read the frame, reassemble the Ethernet frame, and it's going to strip the physical information, and then it's going to strip the logical address information known as your IP address, right? And so it's no longer a packet anymore. All right, it's going to come back into its segment form, and then it's going to be reassembled into the file that you and I click on in like your Windows Explorer or your Google Chrome, whatever browser you use, right? Which I think is a really cool process and actually really simplifies the way data transfer occurs. All right, so how does data know where to go? Well, we mentioned IP addresses, right? And those are your logical addresses that uniquely identify the device and its network. So an example here would be 192.168.1.1, right? And every IP address is broken down into two different parts by something called a subnet mask, and we'll detail that here in a little bit. And so we have a network ID portion, which is your 192.168.1, and then we have your host ID, which is 1. Now, this network ID, it's like a city, right, and a state, and I guess maybe your street name. And then we also have your host ID, which would be like your house number, all right? Another thing that's really worth mentioning is that the IP addresses, right, the way they appear, note that these little dots, right, between your 192, then you have your dot, then your 168, then your dot, that split up the different numbers, those separate octets, right? And octets are actually just 8 bits, right? And there are 4 octets in an IP address, which means an IP address is 32 bits, so 32 zeros and ones. All right, like I just said, we're going to touch on subnet mask now and detail that in a little bit. Now, a subnet mask is just a group of 4 numbers that define a computer's network, all right? So look here at the model that I have at the bottom, all right? The 255s represent the network portion of an address, all right? So 192.168.1, just like the example we saw earlier, okay? And the 0 represents the host portion, all right? So that's like your street address. In contrast over here, everything is represented by 255 is going to be your network portion, all right? Now, this is really important for us to keep in mind as we learn this, all right? And we're going to revisit this throughout the course. All right, so finally, our last objective, types of local area networks, right? We have wired local area networks that comes in different forms. And these wired local area networks, each PC is connected to a central connecting device. Does that sound familiar? We talked about that earlier, right? And whether it's a router or a switch, and that happens by way of an Ethernet cable or a copper-based twisted pair cable. We also have wireless local area networks where each of our devices is going to connect to a network by way of a Wi-Fi signal. And that transmit data ultimately onto a wired network. All right. And the host on this network will connect through a wireless access point. Right? So this is a great alternative to your wired network. It definitely provides a level of convenience and flexibility that the wired network just doesn't. And finally, we have a very special type of local area network called the virtual local area network, or a VLAN, right? And in a VLAN, devices are based or grouped based on their functions. So keep that in mind. Physical location of these devices does not matter at all. You can have 2 devices sitting right next to each other, but they're treated as if they're on completely different local area network, right? So it's a really cool technology, and it's something that make it definitely a lot easier for you to manage your network and keep some devices more secure, All right. And it provides a different sets of right to different devices based on their organization. All right. Thank you so much for joining me here. Let's do a quick recap of our agenda again, okay? So we covered local area networks, and we talk about what local area networks are, right? And we discussed data transfer in general on a local area network, how data get from one place to another. And also, we talked about the different types of local area networks, all right? I'm really excited to continue our journey through networking fundamentals again, so I'll see you again in Module 2.